All right, greetings everyone. Welcome to the video for section 3.8, finishing up our study of chapter 3. We'll be talking about some inverse functions of some of the types of functions we've seen in this chapter. All right, so looking here, we're given two power functions and a root function, which, remember, a root function is actually the same as a power function because I could rewrite this cubed root of x minus 4 is x minus 4 to the 1/3 power. And we're asked to find the inverse functions here. We've talked about inverse functions before, back in chapter 1. And recall that what makes something an inverse function is it switches the inputs and outputs of a function, right? So if we want to find the formula for the inverse function of g of t here, well, the way we can do that is we'll start by, I'm just going to write this as g equals 2t cubed, plus 1. And then because inverse functions switch the inputs and outputs, I'm going to switch my input and output variable here. So this will now become t equals 2g cubed plus 1. And then I want to isolate the output variable here, the g. Okay, so get that alone. So the way we can do that, we just studied this in the prereq material, subtract 1 from both sides. So we will have t minus 1 equals 2g cubed. We cannot combine the t and the minus 1 because they're not like terms. Can then divide by 2 to isolate the g cubed term. So we have t minus 1 over 2 equals g cubed. And then to finish isolating the g cubed, or the g there, we need to do the opposite of the power there. So opposite of a cubed root, or excuse me, of a cubed is a cubed root. And when we do the cubed root on the left-hand side, we need to do it to everything, so that t minus 1 over 2 is under the cubed root. And so what we end up with then is g equals cubed root of t minus 1 over 2. But because we're doing an inverse function here, recall that our notation for inverse function is that kind of -1 exponent. So we'd have g inverse of x equals cubed root of t minus 1 all over 2. Okay, and this here would be the formula for our inverse function. All right, so that's for that one. Let's look at the next one. So this h of x equals 9 plus 2 times the cube root of x minus 4. So I'm going to approach this one a similar way. We'll start by writing this h equals, and actually I'm going to write a little bit further up. So if h equals 9 plus 2 times the cubed root of x minus 4. Then we'll switch our input and output variables. So this will become x equals 9 plus 2 times the cubed root of h minus 4. We'll start to isolate the h there. So we'll subtract 9 from both sides. So end up with x minus 9 equals 2 times the cubed root of h minus 4. We need to isolate the cubed root term, so we'll divide by 2 on both sides, okay, because the h and the 4 are underneath the cubed root, so we can't do anything with them yet. So then we have x minus 9 over 2 equals the cubed root of h minus 4. So now we need to undo the cubed root, which we do the opposite of that, which is cubing. So we'll cube everything. It's kind of the opposite of what we did in the last one. And again, on the left-hand side, when we cube everything, we cube everything. So not just the x minus 9, not just the 2, it's that whole thing cubed. So we now have x minus 9 over 2 cubed. On the right-hand side, the cubed root and the cubed have canceled out, so we have h minus 4. And then we can finish isolating the h by adding 4 to both sides. Notice the 4 is outside the stuff being cubed on the right-hand side, or on the left-hand side, excuse me. So that does not get combined, so we just have x minus 9 over 2, that cubed, plus 4 equals h. Okay. And again, I'm going to go over here where there's space. We'll use that inverse function notation. So we'll write this as h inverse of x equals x minus 9 over 2 cubed plus 4. Okay. And that would be our formula for the inverse there. Wonderful. For both of these, if you need to go back in the video and rewatch or slow things down, please do that. And also let me know if you have questions about how I did these problems. And let's now look at finding inverses of rational functions. Okay, so here we have two rational functions, f of x and v of t. Let's find their inverses. So starting with the first one up there, the f of x equals x minus 1 over x plus 2. We'll again write this, just like we did in the other ones, as f equals x minus 1 over x plus 2. And then just like we did with the previous functions, we need to switch the inputs and outputs. But notice that when we do that, we have two input variables over here, right? X on both the top and the bottom. So when we switch, both of those need to become f's. So what we have now is x equals f minus 1 over f plus 2. And we need to isolate the f. Now notice that's a little bit more challenging here because we have f's in both the numerator and the denominator, but we can handle this. So we'll start by getting the 1 out of the denominator. So we'll do that by multiplying by f plus 2 on both sides of the equal sign. Okay, when we do that, these cancel. Let's have f minus 1 on the right-hand side. And on the left-hand side, just like we did in some of the prereq material, I'm going to distribute the x through here. And so what that'll give us is xf plus 2x. And then because we're trying to isolate the f's, we have f's on both sides of the equation. What we want to do is get everything with an f on the same side. So to do that, what we will do is take the f from the right-hand side and subtract it on the left-hand side. And notice when we do that, cannot combine the xf and the f because they're not like terms, so it'll just be xf minus f plus 2x equals negative 1. And then we also want to move the 2x to the other side. All right, so that we have only things with f's left on the right-hand side, or left-hand side. So when we do that, we now have xf minus f equals, and we have negative 1 minus 2x, because those cannot be combined as they're like terms. And then what will we do from there? Well, notice with those two terms there on the left-hand side, they both contain an f, right? So because each term, both the xf and the f, contain an f, we can actually factor that out. So we'll go back over here. So I'm going to factor an f out of each of those terms. When we do that, the first one will become x minus just a 1 equals negative 1 minus 2x. And then we need to divide by x minus 1 on both sides. And so then we have f equals negative 1 minus 2x all over x minus 1. Or again, we could, because we're finding inverses here, we'll use our inverse notation to write that as f inverse of x equals -1 minus 2x all over x minus 1. Okay? So there we go. And finding the inverse for the second one, that function v of t, would be a similar process. All right, that's where I'll leave it for now. Thank you for watching.